This is the last part of this experiment and interesting part of the experiment. And we are going to measure impulse. So impulse is, if you look at the theory, it is force times time. So to measure the force exerted during the collision, I have here one force sensor. So I am going to attach one force sensor with this. Okay. And another force sensor with the card 2. And when I collide this force sensor will exert force on each other. So the force on card 1 is from sensor 1. Force sensor 1. Force on card 2 is from sensor 2. Right now there is no force, but there are some numbers, so we have to zero it. So how do we zero it? Just click here 0, and everything is 0 now. And another thing we have to do is, we are assuming the direction of the force is positive this way. So when force exerted on this, force is this way, and force exerted on car 2, that's in the opposite way. And so we have to reverse one of the direction of the sensor. Let's do that. From here, which is experiment, we have to set up the sensor, here. So on sensor, we have one sensor here for force sensor, another for this one. So I am going to reverse the direction for 2. Okay, one of them has to be reversed. All right. So, and I think there is, after reverse, there is some number. Let's zero it again. All right. So now we are ready to exert the force here. So first part I'm going to do here with I'm going to do it here with let's see, let's keep it here. Since the time is very short, so we need to collect more data. So we need to also change the data collection. So sampling rate, it says set to 200. Done. And I already did 0. Now okay, so I'm going to collide it. Okay, let's stop here. So let's analyze this. Let's magnify this, and then you see data collection is 200. That's correct. So if you look at carefully how the force is changing in the sensor 1, which is force on card 1 due to card 2, and this is force on card 2 due to card 1. So they are exactly mirror image. That means force exerted on card 1 is equal and opposite to the force exerted on car 2. Doesn't matter if they are moving or not, one is big or lighter, that's the Newton's third law. So let's calculate the impulse, which is force times time. Time is our x-axis, so we are going to find the area under this curve. So which is linear, this is integral. We are going to calculate for both. So if you look at the area, one is 0.1646, another is 0.165. So pretty close. There's a little bit could be from the zero line. We have to calculate the average force. Average force. So average force is 0.165 and another is 1.64. 1.65, 1.64. So average force is close, and that it should be. So I'm going to repeat the same thing, but now I'm going to put the load on the car 2. And now this is my truck, this is my car. So let's collect this again, and let's do the 0 again one more time, because that gives a little bit error. Start. So let's highlight this and then find the area which is the impulse. Integer for both. So this gives us impulse 0.218 impulse Newton second. And also let's calculate the average force. Mean values are 1.55 and 1.56, so 1.558 and 1.564. So this should be close, and it is. Okay, so those numbers have to go here in the table 5, and based on these results you have to explain in your lab report. And also from the impulse values you have to calculate what's the change in the momentum. So if you need any hints for that, go back and look at this introductory and theoretical part here. So there is something very different here. Okay, good luck.